Hello and welcome to our webinar about automation of data warehouses, data lakes, and data stores. My name is Petr Hajek, and I'm information management professional with more than 20 years of experience in data management, data warehousing, and business intelligence in roles of data architects, solution architects, and strategic and management consultants. I used to work for companies like Citigroup and KPMG. Now I work for Profinet, and Profinet is a software house with more than 22 years on the market, located in Prague, and company which employs more than 500 experienced and enthusiastic professionals. Profinet serves for clients in industries spanning from finance to insurance, over telco and other industries, including, for example, some other industries. Data warehouses, operational data stores, data lakes, and other similar systems are specific pieces of software because they accumulate and integrate large amounts of historical data from various heterogeneous data sources. These systems are highly complex and robust. We may see that these systems very often end up undocumented, complicated, and fragile. It means that they can get very easily broken. When we develop, maintain, or operate these systems, we face three major challenges. The first challenge is manual coding, because we need to prepare tons of code, lines of code, typically SQL code, and we very often prepare this code manually just by typing. We also need to organize too many people. We need to organize people like business analysts, developers, database specialists. We need to employ quality assurance people, code reviewers. We need to work with testers, and we also need to organize users to get their acceptance on what we delivered. And also we need to have huge teams who operate and support our data systems. And a specific challenge when we talk about data systems is lack of transparency. There is a specific term, this is data lineage, which describes that we need to understand the dependencies of our data outputs on data sources. Simply, we need to understand what happens with our data inside of these robust systems. And very often, we do not understand, we do not see into these systems, and these systems seem to be like black boxes. Well, if we want to address these challenges, we have to first reduce the complexity. We can reduce the complexity by identifying very atomic or elementary building blocks. We may say that data-oriented solutions are nothing more than orchestrated steps of transformations and storage of data. We start with source data, then we transform it or integrate it into new next data platform. Then we transform it again using a specific business logic, cleaning the data, integrating the data, reshaping, restructuring the data, and storing the data again. And then again and again, we transform it to the last step before we can present the result to the end users. But if we look inside of these data systems, we will see that they are made of scripts, typically SQL language scripts. And there are, as I already mentioned, thousands of these scripts, maybe tens or hundreds of thousands of the scripts of code lines. And these scripts represent both the data and data transformations on all the architecture data layers of the system. And if we want to address the first challenge, which is manual coding, we need to take the scripts and we need to understand them, and we need to decompose these scripts to 3 pieces. First, we need to understand what is static inside of the script, which means what repeats in all the scripts of the same kind. What is static, what is repeatable, will be captured in what we call templates. What is dynamic, what is variable in these scripts will be captured by metadata. For example, list of columns and names of tables of our source data can be easily described by metadata, and other pieces of the code can be captured by templates. If we want to save some time or effort, we may try not to write down everything in metadata, and we may try to define rules, which means we can define derivation rules that some specific metadata can be derived from basic metadata. I will give you an example on the next slide. We can imagine generating the scripts in analogy with printing envelopes. If you want to print many envelopes, you will prepare a list of addresses of your maybe business partners, and you will prepare a table, maybe in Excel, with all the addresses. On the other side, you will define template, which will define what will be printed on the left upper corner and what will be printed on the bottom right corner. And then you will go back to the addresses and you will check whether the addresses are correct. So you will define some validation rules. You may validate if the zip code corresponds with the name of the city. This is an example of rule. Or you can derive some missing pieces of the addresses just based on the zip code again. When this is done, and when you believe that your metadata, your list of addresses, is complete and correct and accurate, you will simply put it into the machine and you will press a button and you will either print all the envelopes or you will analogically generate the scripts which can be deployed on a target database engine afterwards. Metadata, templates, and rules make up what we call framework. And this framework is then used for building, automatic building of the target data solution, our data warehouse or data lake or any other type of data system. When we again look at what is the outcome of the framework, we will see those scripts, thousands of scripts, but now these scripts are not prepared manually, these are generated. And the advantage is that we will perfectly understand what will be inside of these scripts. We will not need to apply any reverse engineering on the scripts because we will know at the beginning what will be there, what will be generated. So even if we want to understand, for example, the data lineage, we will be able to visualize the data lineage just using the metadata, not analyzing those scripts. Well, the framework does not come for free. You will need to invest some time and money into the framework before you start getting the benefits of it. Sometimes it's difficult because your business sponsors or business stakeholders wish to have immediate results. They want to have some prototypes, some first increments of the data system. They want to see first reports, first analysis coming from the data system. It is wise to convince them that you will need to invest some time into the framework, and after that you will benefit from having the framework. And in my experience, the break-even point, which means the point in time when the initial investment starts paying off, comes earlier than after first 12 months of the project. So within the first year of your data project, you will already start earning money on your initial investment into the framework. If you want to convince your business sponsor that it is really wise to invest into the framework setup, you may refer to Gartner. And Gartner says that specifically in the case of data warehouse automation, you will typically get 200 or even 400 increase in your productivity if you bet on the automation framework. And my experience when we talk to our clients, and if we want to be very conservative and do not make high promises, we say that at least 30% of your time and costs on development of data system will be saved within the first year of your project when you use data automation approach. Well, people often say that it is easy to generate scripts that create tables, partitions, or other data objects in your data platforms like relational databases and so on. But they say that the problem is much harder when we want to automate the process of development of data transformations. Okay, let's have a look at it. First, those data transformations are of two types. There are technical transformations and business logic transformations. The technical ones are processes like surrogate key assignment, which means you need to automatically assign some internal technical identifier key for all the instances of your source data based on some natural IDs, natural identifiers, which come with the data from the outside world. This is something that can be quite easily automated using some specific patterns. Another example is consolidation or deduplication, which means removing the duplicate records in your source data. Another example, very typical, is historization. There are many patterns for historization of your data in your data systems, like a simple pattern for creating snapshots, or more sophisticated patterns like slowly changing dimensions and so on. Well, these technical patterns can be very often found at many data-oriented solutions. But then we will need to look at automation of business logic transformation, which means the rules, how to integrate, how to combine the data, how to clean it, how to calculate something based on the data using some specific business logic and so on. And people often say that it is not a good idea to try to automate this process, to generate the scripts, that this is always better to code it manually. And I would disagree. And my approach is to, again, decompose the business logic into pieces, and each piece of the business, each atomic piece of the business logic or the business transformation should be described by a specific pattern, or you should always use a specific predefined pattern for description of a specific piece of business logic. And again, there are typical patterns. The easiest pattern is mapping one-to-one, which maybe is not even business mapping. It is technical. So you take the source and you only transform it technically to a new, maybe database platform. But then you need to do something what business wants you to do. So you need to do some column level mapping. You need to decide that you will take these two columns in your source data, you will put them together, you will transform it, and you will store it in a new target column in a new table in the next higher layer of your system. This is still quite simple pattern. But then the third pattern is the most important one. And I'm convinced that this is the most frequent pattern that you will find in all the data-oriented solutions when we talk about business logic transformation. This is the pattern that I call join and lookup. It can be also explained if we borrow a terminology from SQL language, like select from a main table, left join other table on a specific condition, left join other table, left join, and left join. Typically, we use these additional left joins for references into code lists or other reference tables, but we can also use them for integration of multiple data sources from different systems. And if we are consistent in our analytical approach, we can really atomize the business logic to these simple patterns, and we can define these joins and lookup for almost everything what we wish to do with our data. Yes, that's true that there are some other patterns that we will need to use sometimes. These are patterns for aggregation of our mappings or transformations and unioning. But that's all. These are the 5 business logic patterns that we will need if we want to capture any kind of business logic transformation. The second challenge, if you remember, was that we need to organize too many people. Now let's have a look at the roles that we will need in the process, in the life cycle of when we develop new functionalities, new increment or a new version of our data system. It starts with business analyst. Business analyst understands the business requirement, and after the necessary analysis, he or she writes a business specification in plain language, in plain English, let's say. Then technical analyst comes, reads the specification, and does the miracle. And the miracle is that the plain language is translated into highly structured metadata. And if it is simple, if the business requirement can be implemented using the existing framework, which means existing rules and templates and a structure of metadata, then the technical analyst simply puts it into the system checks the metadata on the input, and if everything is correct, then the new increment of the system is automatically generated and deployed on a testing environment. So it comes very quickly, very quickly to business users, and these business users check whether what they get is what they really wanted. It may happen that they are not satisfied at the first attempt, and they reject this new increment. So it goes back to the technical analyst, or maybe even to the business analyst, if, for example, business analyst didn't understand perfectly what the business users, wanted to have. And at the end, new version of metadata, modified metadata is prepared, and the cycle repeats. And it can be repeated several times. And the advantage is that we can repeat the cycle if we have a good framework for automation. We can repeat it even several times in a day. So we do not need to wait for the next testing phase, 2 weeks, 3 weeks, 1 month, or we do not need to wait for the next release. So we can work in sprints. We can work very quickly. So at the end of these first few cycles, we typically satisfy our business users. They are happy with what they get, and they accept the increment or the change to production, and it's deployed on production environment, and it's handed over to the operation and support team, and the new functionalities, new pieces of the systems start being operated. It may happen that the business requirement is somehow more complex. It's more difficult to deploy it using the existing framework, or it's maybe even impossible to implement it using the existing framework. And in that case, the technical analyst should identify this situation and should contact the framework engineer asking for an extension of the framework, which means extension, creation of a new template, extension of a template, addition of new rules, or maybe even changing the structure of metadata in order to be able to satisfy the business requirement. There's an example of such framework extension. For example, business needs to add new data source, and this new data source is implemented in a database platform, which is not supported by our framework. In that case, the framework engineer needs to prepare new template or templates that will be able to ingest data from a new database platform, for example. When this is done, then it goes back to the technical analyst. He or she gets the instructions what kind of metadata should be prepared for this extended piece of the framework, and the cycle can continue. Well, these business analysts, technical analysts, and business users can be organized, if we follow the agile methodology, can be organized in squads, small teams of people where we combine the technical and business knowledge. And these squads can operate in parallel, so they can deliver changes or increments of the system, our data warehouse, data lake, data store in parallel, which means that there can be many parallel changes being implemented almost at the same time. Okay, if you are not 100% convinced that we can really automate development of these huge systems without any manual coding, manual scripting, I can tell you about a successful project in this case study. The project was data warehouse for regulation of gambling industry in an European country. And the request, the customer was Ministry of Finance, and the request was to deliver a data warehouse that will be able to collect and process, validate, and transform a large amount of data coming from all the registered gambling providers in that country. And the purpose was to process specific validations and reporting and checks and controls on the data for various regulatory purposes. Today, this data warehouse holds more than 25 terabytes of data, and the target capacity is 70 terabytes. It's built on data layers architecture, which means that there are multiple data layers, and it contains tens of thousands of database tables. And it's really necessary if you want to maintain such a huge system, which has more than almost more than 100,000 of tables. You need to use the automation, and you need to use what we call prescriptive metadata driven approach. In this case, in this project, we were able to deliver the system in a record time of 5 months. And there was only a small team of 5 professionals: solution architect, database specialist, project or delivery manager, and 2 SQL developers. We started not with directly building the system, but we started with building the framework. It took us a few weeks, but when the framework was done, we only prepared the metadata in cooperation with analysts from the Ministry of Finance. So these analysts didn't understand anything about databases, anything about the code, but they only provided the business logic in the structured form of metadata. And this way we were able to deliver the first version of the system, and we started what we call the public testing phase, which means that all the gambling providers in the country were able to connect to the system and start sending the real data into the system and get all these validations and feedback about the data. So within 5 months, the system in the first version was ready. And the truth is that there was 99.9% of the SQL code automatically generated. So only few procedures, like few specific procedures were manually scripted, and really almost everything was manually coded. The advantage was that we wanted to change something. We didn't need to change the code. We only changed the metadata. In this project, we used specific methodology and a framework that we call data frame. And what I like most maybe about the project is that we used PostgreSQL open source database platform for both, for the target system, for the data warehouse itself, and also for the framework as a repository for the framework. Well, let's summarize what are the advantages of smart automation of data-oriented solutions. First, we do the analysis by reusing the predefined patterns. So there is high discipline of all the analysts because their results follow the predefined patterns. We decrease the creativity of all the analysts. The results of this analysis are always readable for both, for humans, for people from the business, for analysts, and also for the machine, because the machine can use it and automatically start generating pieces of the future system. We foster prototyping, and this way we can enjoy what we call license to make mistakes at almost no cost, which means that if somebody makes mistake, business does not explain perfectly what they want. Business analyst does not understand perfectly what business wants, or does not provide the specification accurate, or the technical analyst does not understand something perfectly and does not translate it into the metadata perfectly. All these are examples of mistakes, but we do not need to be worried. We simply can make the mistake and we can see immediately what the system would look like if we implement it by based on these inputs. And then the business or testers can immediately see if this is what they wanted to have or not. And then we can repeat the cycle several times. It costs us almost no time and almost no money. And not only business users or testers give us the feedback, we get even immediate feedback from the framework itself, which means that if we provide metadata, which is incomplete, inconsistent, or inaccurate, then we get the immediate feedback from the framework that based on such metadata input, the system cannot be built. And of course, we eliminate the manual coding, which means, for example, that we also get rid of things like quality assurance and code review. We streamline the whole development lifecycle and we minimize the time to market. So as I said, we can really work in sprints, in short periods of time, and we can deliver constantly changes in parallel development. We can have parallel development teams who deliver increments of our system almost constantly. And the last advantage is again about the data lineage, which was the third challenge. By using the metadata-driven approach, we can understand upfront what will happen with our data. We can draw the data lineage charts even before the system is implemented. So there is no black box, there is no hidden information. What will happen with our data inside of the system? We will know everything about the data processing and data lineage even before the system exists. Well, the systems built based on what we may call traditional approach were undocumented, complicated, and fragile. But the systems which are built based on smart automation approach will be transparent, the processes and people will be organized, and we foster agile. And that's all. Well, don't hesitate and automate, and nothing all matters. Thank you for your attention, and we will be happy if you provide us with feedback on this webinar using this QR code, which will redirect you to a survey. And in return, you will get the additional slide with few tips for development of data-oriented solutions. Thank you. See you. Bye.